This is part 4 of my do-it-yourself 3D printed, scale Bally Fathom pinball machine. I start to form and assemble the rails. For this I have constructed special posts which hold a plastic strip in position with the help of a groove. The end piece of the side border also has a groove to hold the plastic strip in place. Since I didn't bend the strip beforehand, the groove breaks off the side border. The part has to be 3D printed again. This time I bend the strip first. The strip is then shortened again and again until the length is right. The side border part is 3D reprinted and I screw it back onto the Playfield. The shootout lane is finished with these two rails. I test the shootout with the ball. Here, I am assembling the large ball gate. It consists of 2 posts, a long bridge above them, and a 1.8 mm steel wire bent into shape. The suspension of the steel wire is provided by the rubber rings on the posts. Now I mount a long rail. This is again based on posts with corresponding grooves and a plastic strip. In order to ensure that the ball is safely pushed into the kick-out hole, an appropriate barrier must be installed behind it. Unfortunately, it turns out that the plastic strip is too short and needs to be replaced with a longer one. The rail for the spinning target has to be designed and mounted differently. I'll postpone that until later. I'm testing the large rail a bit. I have to check whether the ball can sink the drop targets and whether the ball also reaches the kick-out hole and falls in there. A rail must be attached to the kick-out hole. To ensure that the kick-out hole remains visible to the player, this is made using a wire and drilled posts. The rail for the spinning target has to be specially constructed because it is very narrow and lighting is mounted underneath. I do this using Inkscape based on the plan that I created for the milling. I use the Bezier curve tool in Inkscape for this. This allows you to draw straight lines and then bend them to give them the desired shape. At each end of the rail I have to form a circular curve and provide a hole. In order to be able to process it better, I copy the rail and insert it outside the plan. Unnecessarily copied parts are deleted there. The holes for the bulbs are modified, unnecessary parts are deleted. For the middle posts only holes for the screws are needed, these are inserted here, the rest is removed. Now the drawing is moved to a separate level in Inkscape and the transparency of it is removed. Then it is filled with color. The holes at the ends of the rail must be cut out. The circular areas and the color filling are grouped together. The group is then moved out of the existing drawing. This is the desired shape of the rail that remains. The parts that are no longer needed are deleted. For some reason, there is a small gap between the color fill and the circular areas. This needs to be filled. I'll check quickly whether the rail fits. Then it will be exported as plain SVG. The exported file is opened briefly to check whether the export was carried out correctly. The exported file is then renamed accordingly. The file is now imported into Tinkercad. The desired height of the rail of 2 mm must still be configured. This is then exported as an STL file. The STL file is opened with Cura. In the preview view, I check whether the rail will be printed correctly. Since everything is okay, the rail is also printed in 3D. Here it is. The rail is now screwed to the playfield with posts cut in half and shortened by 2 mm. Since the posts break easily when putting on the rubber ring, I always screw them tight when I do this. It is checked whether the bulb fits exactly into the holes provided for it. In the next part, the bumpers will be mounted. Thanks for watching.